In this short video, we'll give a demonstration overview of the SICK Incorporated optical photoelectric products that can be used and are being used for in-die sensing, die protection, part quality monitoring. The model that we've got right here is as you'll see in the video here, we've got a progressive strip that has been mounted to a slide, and we've got a number of optical sensors that are being used to detect various features, characteristics, or in process attributes and characteristics that would be typically used in the process. We've got quite a number of sensors being featured on our die model right here, and we'll give a quick overview of what some of the functionality and purpose is, and the benefits of using the SICK Incorporated sensors. The very first sensor that we've got, and we've got an annunciation illumination box also featured in our die here, is this one that's on the side. This is our small little, it's a WT2S F131 sensor. It is actually used to detect the edge of the strip. This is to verify that material is present, continue with the progressive forming process, and that if the material has passed this and run out, then it signals to the control system to prepare for a stop. Very small, very easy to use, one-sided mounting background suppression sensor. The second sensor that we've got featured on our die model here is mounted in an opposed pair. These are our WE and WS2S sensors that are actually looking across the die, and as the strip, which has vertical features, comes in front of that sensor pair, breaks the beam, and this could be used very typically for strip feed or verifying that vertical attribute is present with the particular part in process. The third sensor that we've got featured in our die sensor application right here, we've got a remote optics opposed pair. These are actually mounted in a little C-frame bracket, and it's an over-under, and then as the strip breaks this particular photo pair, output is basically detected. Could be used to look for the edge, or in the case of, in this particular strip where we've got a hole, we can verify that that hole is present, it has been perforated correctly. This is a remote optics type setup, and so it works with a remote amplifier that we actually have in our little small die junction box that we have actually on our die model. The smaller photoelectric optics with the remote pair will be used to fit in smaller space requirements and where space constraints are significant. The next sensor that we've got in our die model here, it's a pair of linear array photo or fiber optic cables that are shooting across the die. We've got about a 4-inch separation with a vertical array of about 1 inch, and these actually then connect up to a remote fiber optic amplifier, and we get a digital readout. The display will tell us what the set point is, and then what the reading value is, and we can use this for a discrete output. We can actually use it to even gauge and verify that the material is correct height, and in this case that these vertical tabs have been formed correctly. The next sensor that we've got featured on our die model here, this is a slot sensor. This is the WF50 from SICK, and this is actually used, as we can see there's a horizontal projection that actually sticks out on the opposed side of this strip, and we can use that for strip feed, or we can even use it to look for the slots that are in this particular strip, or verify that we're on gauge nested correctly, or in this case here, verify that the hole is missing on that particular portion of the strip. The next pair we've got, or the next sensing solution, this is an opposed pair emitter receiver. This is the SICK WSE and WSE4S pair. We actually have these, you might have a look at, but we have these on a slight tilt. the sensor that's on the near side to us is actually elevated, and we're actually sending a beam of light, visible light, across the beam, or across the strip. And this actually gives us the ability to even verify strip feed when we have a very, very thin strip material like we have in this particular case right here. You can see that the small edge of the strip, this strip is about 1/8 of an inch thick, and we can actually break the beam. The effective beam is actually larger than that by the fact that we're actually on a slight angular tilt with the effective beam between the emitter and receiver. Very good when trying to detect strip feed with flat coil stock. The next sensing solution that we've got in our particular die here is a background suppression, a small laser-based photoelectric background suppression unit. We've got this actually mounted on a clamp bracket, and what we're really featuring here is the fact that you can actually have some of these sensors mounted on the periphery of the die so that it is not necessarily embedded in the tooling, and when room and space is not able to deal with fitting in there, then these types of small but very precise based sensors can give capability and options that you normally wouldn't find with traditional photoelectric sensors. Two other sensors to cover in our die model here. We have at the end of the die, we've got a small set of part out detectors, and these are small light curtains for all intents and purposes. These are not safety light curtains, but these have a 2.5 inch window, and any of the parts that typically either get blown off or ejected off of the end of the die, cut off from the strip, they sometimes can travel or be ejected in a random fashion. We're having a set of light screens that have an area of detection. This gives us the ability that we'll see that no matter where that part is actually being blown off or ejected into. So these come in a variety of different lengths and give the ability to get part out detection no matter how that part's going to travel off the end of the die. And then finally, we've got a long-range laser-based optical sensor that's being used here. This is one that again would be used for long-range sensing. It has a sensing range out to 1 meter, and again would be used for where we don't want to or we don't have room to get close to the work or close to the process, but we can be anywhere from 1, 2, 3 feet away, look into the particular die and take a look at characteristics and features on this particular strip that's being run. In the case of our example here, we've got the small laser spot you can see on the edge of that vertical tang, and we're verifying that that is there. And if that is not bent at the correct angle, if that's either underformed or overformed, we'll be able to detect that with this particular sensor. So that's kind of a quick overview of just some of the ways that the SICK incorporated sensors with sensor intelligence can be used for improving quality, eliminating die crashes and process crashes, and ensure that each part that's formed in every stroke is a good part with using sensor technology.